Hello everyone, and welcome to the channel. Today, we're re-diving into a topic that has completely revolutionized the way we build and deliver software: Devops. If you're a developer, an IT operations professional, or just someone curious about how modern tech companies ship products so quickly and reliably, you're in the right place. In the next 10 minutes, we'll break down what DevOps is, why it's so important, and how you can start applying its principles. So grab a coffee, and let's get started. First things first, what exactly is DevOps? The name itself gives us a clue. It's a combination of development and operations. But it's not just about merging two teams. DevOps is a culture, a philosophy, and a set of practices that aims to shorten the software development lifecycle and provide continuous delivery with high software quality. Think of it as a bridge between the people who write the code, the developers, and the people who deploy and maintain that code, the operations team. Historically, these two groups often worked in silos. Developers would write code and then, essentially, throw it over a wall to the operations team to handle. This often led to a lot of friction, misunderstandings, and delays. The developer's main goal was to introduce new features, while the operations team's goal was to ensure stability. These goals can sometimes be in direct conflict. You've probably heard the classic phrase, "It works on my machine." That's a symptom of this old siloed way of working. It promotes collaboration, communication, and shared responsibility throughout the entire life cycle of a product, from the initial idea all the way to production and feedback. So, why should you care about DevOps? The benefits are huge. For businesses, it means faster time to market. By automating and streamlining the development and deployment process, companies can release new features and bug fixes much more quickly. This agility is a massive competitive advantage. It also leads to improved quality and reliability. When development and operations teams work together, they can catch issues earlier in the process. With practices like continuous testing, code is constantly being checked for errors, resulting in a more stable and reliable product for the end user. And finally, it boosts team morale and efficiency. When you remove the friction and blame games, you create a more collaborative and positive work environment. Engineers are happier and more productive when they have ownership and can see the direct impact of their work. Now, let's talk about the core principles or pillars of DevOps. You'll often hear about the CALMS framework, which stands for Culture, Automation, Lean, Measurement, and Sharing. Let's break that down. Culture is the most important part. It's about fostering trust, collaboration, and a willingness to experiment and learn from failure. Without a supportive culture, none of the tools or processes will matter. Next is automation. This is a huge one. The goal of DevOps is to automate everything that can be automated. This includes building the code, running tests, deploying to servers, and even monitoring the application in production. Automation reduces manual errors, speeds up the process, and frees up engineers to focus on more creative and valuable work. Think of it as building a well-oiled machine that delivers software for you. Then we have lean principles, borrowed from manufacturing. This is all about eliminating waste and focusing on delivering value to the customer. It means working in small batches, getting fast feedback, and continuously improving the process. Instead of working on a giant feature for 6 months, you release small, incremental updates. Measurement is next. You can't improve what you don't measure. DevOps relies heavily on collecting data and metrics at every stage. This could be how long it takes for code to go from a developer's laptop to production, the number of failed deployments, or the performance of the application. These metrics help teams identify bottlenecks and make data-driven decisions to improve. And finally, sharing this ties back to culture. It's about sharing knowledge, tools, and responsibilities. When a developer understands the challenges of deployment and an operations engineer understands the structure of the code, everyone benefits. The success or failure of the product becomes a shared outcome. So, how does all this work in practice? It's powered by a set of tools and practices often referred to as the DevOps toolchain. This toolchain covers the entire software lifecycle. Let's walk through a typical workflow. It starts with a developer writing code and committing it to a shared code repository, like Git. This is the plan and code phase. Once the code is committed, it triggers an automated process called continuous integration, or CI. A CI server, like Jenkins or GitLab CI, automatically pulls the new code, builds it, and runs a suite of automated tests. If any tests fail, the developer is notified immediately. This ensures that new code doesn't break the existing application. This is the build and test phase. If all the tests pass, the next step is continuous delivery or continuous deployment, often shortened to CD. In continuous delivery, the built code, now called an artifact, is automatically deployed to a staging environment. This is a clone of the production environment where final tests and quality assurance checks can be performed. Once it's approved, the code can be deployed to production with the push of a button. Continuous deployment takes it one step further and automatically deploys the code to production if it passes all the tests without any human intervention. This is the release and deploy phase. Tools like Ansible, Puppet, and Terraform are often used here to manage the infrastructure as code, and technologies like Docker and Kubernetes have become essential for packaging and running applications consistently across different environments. But the job isn't done once the code is in production. The final phases are operate and monitor, DevOps. Teams use monitoring and logging tools like Prometheus, Grafana, or the Elk Stack to keep a close eye on the application's health, performance, and usage. They look at CPU usage, memory, response times, and error rates. This continuous feedback loop is crucial. If an issue is detected, the team is alerted, and they can quickly work to resolve it. The insights gained from monitoring are then fed back into the planning phase for the next development cycle. This completes the infinite loop of DevOps: plan, code, build, test, release, deploy, operate, monitor, and back to plan. Begin by identifying a small, low-risk project. Introduce one new practice at a time. Maybe start by setting up a version control system like Git. If you aren't using one already, then automate your build process. After that, introduce some automated testing. Each step you take builds on the last. Focus on the culture. Start conversations between your development and operations teams. Encourage them to share their challenges and successes. Create shared goals. Maybe the goal is to reduce the number of production failures or to decrease the lead time for changes. And finally, never stop learning. The world of DevOps is constantly evolving. New tools and techniques emerge all the time. Stay curious, read blogs, watch tutorials like this one, and connect with others in the community. The journey to a mature DevOps practice is a marathon, not a sprint. It's all about continuous improvement. To recap, DevOps is a cultural shift that brings development and operations together to build and deliver software faster and more reliably. It's built on the principles of culture, automation, lean, measurement, and sharing. By using a toolchain that supports continuous integration, continuous delivery, and continuous monitoring, teams can create a high-velocity feedback loop that drives constant improvement. It's not just a buzzword, it's a fundamental change in how we approach software engineering in the modern era. I hope this overview has given you a clear understanding of what DevOps is all about. We've only scratched the surface today, of course. There's a deep world of tools, techniques, and strategies to explore for each phase we discussed. If you'd like to see more detailed videos on specific topics like CI/CD pipelines, infrastructure as code, or monitoring tools, let me know in the comments below. Your feedback helps me create the content that you want to see. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and consider subscribing to the channel for more content on software development and technology. Don't forget to hit that notification bell so you won't miss our next video. Until next time, happy coding!